For this problem, we'd like to find the length of the portion of the line y equals 4 minus 2x that lies within a circle of radius 3 centered at the origin. Let's take a second and try to picture what this would look like. If we have the equation of the line y equals 4 minus 2x, it's going to kind of come down something like this. And if I have a circle of radius 3 that's centered at the origin, it's going to come around something like this. So what I'm really looking for in this problem is I'm looking for the length of this section right here that stretches from the circle top right here all the way down to this other edge of the circle here where it's intersecting with the line. In order to find the length of that, I'm actually going to have to find the distance between the intersection points, between those two coordinate points. So how do I find where the line intersects the circle? Well, what I'd like to do is some algebra based on the equations. Right now, I'm given the equation of the line. The equation of the line is 4 minus 2x. Awesome. Now I also need the equation of the circle in order to do that. Now, because I have a circle of radius 3 centered at the origin, it has a fairly simple equation. It's just x squared plus y squared equals the radius squared. So 3 squared gives me another equation of 9. So that's the equation of my circle. So if I'd like to find the intersection points, what I'm going to need to do is some substitution. So I'm going to put that 4 minus 2x instead of y in the equation of the circle. And now I will have this new equation. I'm going to have x squared plus 4 minus 2x all squared equals 9. Cool. Now, a little bit of algebra I'm going to have to do. The first thing I'm going to have to do is that 4 minus 2x squared. This is usually where people have some trouble. What you need to remember is that 4 minus 2x squared means 4 minus 2x times 4 minus 2x. And there's some middle terms that are going to come into play here. Usually if you think of FOIL, that's what we're going to have to do to multiply that all out. So simplifying my equation, I'm going to now have x squared plus, now I'm going to do this whole FOIL thing. I'm going to go 4 times 4 gives me 16. Minus the 8x on the outside, minus the 8x on the inside, plus 4x squared is equal to 9. All right, so that's just expanding the equation, so now I don't have any parentheses. Now I'd like to combine like terms because I'd like to solve this for x. The x squared plus 4x squared will give me 5x squared. Then here I have a minus 8x, that'll give me a minus 16x there, plus 16 equals 9. Now, the first thing that I notice now is that I've got an x squared and a plain x. If I want to solve for x, I am going to probably have to either factor or use the quadratic equation. Either way, I need one side equal to 0 before I start. So I'm going to minus the 9 over. So now I have 5x squared minus 16x plus 7 equals 0. Now you can try to factor this, and you're not going to have a whole lot of luck. But what we'll need to do instead then is to go ahead and use the quadratic equation. In this case, notice that I'm going to have to use an a of 5, a b of negative 16, and a c value of positive 7. So when I plug that into the quadratic equation, I'm going to have x equals negative b, so positive 16, plus or minus the square root of negative 16 squared minus 4 times a, which is 5, times c, which is 7, all divided by 2 times a, which is 5. All right, a little bit more simplifying here. I like to do what's inside the square root first. And when I do that, I come up with 116. And then I'm going to divide that, divide that by 10. And now that I've done this, I can go ahead and get two different answers. I get one answer by using the plus. 16 plus the square root of 116 divided by 10 gives me my first solution of x equals 2.677. And when I use the subtraction, I get my second answer. So I do 16 minus the square root of 116 and then divide that answer by 10. And I get x equals 0.523. Now, if you notice, all that I found right now is just the x-coordinates of these intersection points. So this point here and then this point down here. In order to use the distance formula, I'm also going to need the y-coordinates that go along with that. So what are the y-coordinates that I need? well, I'm just going to plug my values for x into either of the original equations. Using the line equation is probably easiest. So I'm going to have y equals 4 minus 2, times x, but instead of x, I'm going to have 2.677. And when I plug that in, I'm going to get that y is equal to negative 1.354. So that's one coordinate. For my other coordinate, what I'm going to do is I'm going to plug in x equals 0.523. So I have y minus 2 times 0.523. And this is going to give me the y coordinate of my second point, which is 2.954. So now what I have is I have the coordinates of 2 points. My first point is 2.677, comma, negative 1.354. That gives me one coordinate point, this one. And then my other point that I'm going to do when I do this is the x coordinate was 0.523 and the y coordinate was 2.954. And that gives me the coordinate of that point. So now that I have two coordinate points, I'm almost done with this problem. The last thing that I need to do then is to find the distance in between those 2 points. All right, so we'll give ourselves a little bit more room here. Remember your distance formula. D is equal, let's see if we can fix that a little bit. D is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. All right, so these are just the x-coordinates of each point and the y-coordinates of those 2 points. So when I plug that into my distance formula, then what I end up with is this. I'm going to have d equals the square root of 2.677 minus 0.523 squared plus, instead of y1, I'm going to have negative 1.354 minus 2.954. And I'm going to square that. And that's all under the square root. And when I just plug all of that in on my calculator, I get the distance between those 2 points, which is 4.8165 units.